Good morning. So this is where I will start. That's where I kind of stopped last time. We are going to continue with the normal distribution. All right. Z-scores table and standard normal distribution. Please do keep in mind a standard normal distribution is a distribution with a mean of 0, mu is equal to 0, and sigma is equal to 1. And we can convert any normal distribution into standard normal distribution by using the z-scores formula. So if I have another distribution with mean mu naught and sigma naught, let's say, we can go back and forth. Z is equal to x minus mu over sigma. We can go between these two. All right. And also this is for the population, but for sample, there is a corresponding formula, x minus x bar divided by s. And this is probably what we will be using for the most part. So please do make sure that you are comfortable with doing these things, okay? You go between any normal distribution to standard normal distribution. Standard normal distribution. Please do keep in mind, standard normal distribution has a mean of 0 and sigma of 1. Mean 0, standard deviation 1, or x bar 0, or s 1. This is for sample and this is for population. Now, when you look up the z-scores table, when you're looking up the z-scores table, what you are doing, you are in essence finding the probabilities associated with the standard normal distribution. When you are looking at z-scores table, you're finding probabilities with standard normal distribution, okay? Then based on what you're doing, you may have to go back to the original normal distribution that you're dealing with and find the required or desired values. And you need to be able to go back and forth. Once you understand the logistics of it, one or two problems is pretty much the same thing we're doing again and again. So that's what it is. Now, again, we start off with our standard problem that we have been dealing with a mean of 35,000 and standard deviation of 7,000, okay? So let's do this problem. You have a data set, or you have a population, in this case you can think of, that has a mean of 35K and a standard deviation of 7K. Mean of 35K and standard deviation of 7K. Now, average income is 35,000 and standard deviation is 7,000. Again, in this example, I kind of emphasize the fact that income is normally not measured in terms of average, but rather median, okay? It's measured in terms of median. But I'm using it here as an example by making the assumption that we exclude extreme values, okay? Extreme values, that means people, those who are super rich, making a lot of money, or people, those who are not making anything at all, we kind of exclude extreme values. More likely super rich, not so much the people, those who don't make money, okay? We try to keep them as well. So I kind of use this income because it's easier, okay? So we exclude big numbers, let's put it that way. And mean is 35,000 and standard deviation is 7,000. Remember, standard deviation, it measures the spread of the data set. How far are the data points in the data set with respect to the average? How far are the data points in the data set with respect to the average or the middle or the center of the data points. Now, let's say you are the mayor of the city, you're a mayor of the city that you live in, or you are the mayor of the city that you live in, and you would like to find out about the bottom 5%. So you'd like to know about the bottom 5% of the people, bottom 5% of the people. In your city, you would like to know the bottom 5% of the people in your city. Now, maybe as a mayor, you want to give them special benefits like stimulus check that people are receiving right now. Okay, many people are receiving stimulus checks now. That's kind of actually what the government is doing, calculation. They're kind of finding out who are the people not making enough. Okay, I'm pretty sure they're using some sort of statistical knowledge or modeling to give out this money. It's not that, okay, we're going to give it to everybody. And everybody doesn't really need it either. People, those who have jobs, people, those who have, good income, even in this bad economy, people, those who have steady jobs and doing okay, they should not be receiving the money. People who are in need, who don't have jobs, who are struggling, they are the ones who should be receiving the money. And here, before even I go into the problem, here is something that I kind of want to tell you guys. You guys may want to know these things. This is very important. When government gives money, people are happy. They think it's free money. Okay, and they think it's free money coming in. Who don't take like $1,400 for free? What you do not know, it is bad for you. It's actually, unless you really need it, it's overall bad for people. Free money is bad. It's not good. Because the reason it's not good is this. What in essence happens is this: when you get free money, the prices of things go up. That's called inflation. When you get free money, when government is giving free money, the prices of things go up and your affordability goes down. That's a fundamental principle that we should know about. This is how the economy works. It's a demand and supply. If you have more money, the prices of things are going to go up. It's natural. That's one thing. Another thing, right now, you guys don't realize, maybe many of you, because you're too young, home prices are going through the roof. It's crazy. We can't buy a home. We can't afford a home. Ordinary people like you and me. It's so expensive. You live in this area, Salinas. Just the other day in Salinas, I heard a home was listed for $710,000. It was sold at $780K in Salinas. Where is this money coming from? They asked for $710,000. There were multiple overbids, and at the end, it was sold at $780,000. This is bad. Where is it coming from? It's coming from the free money. So you get $1,400, now you can't buy a home. Who is getting rich off of it? When you buy products and services, it shows up in the stock. It shows up in the stock. Ordinary people, not many ordinary people directly own stocks. People, those who have good paying jobs, people, those who are in the executives, and people, those who work for big high-tech companies, engineers, a lot of them, they get stock options for free, pretty much. They call it this or that, but bottom line is that free money. They say that you work hard and you get benefited and blah, 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 whatever. But bottom line is they are getting compensated in terms of stocks, and your free money, where does it go? Company's bottom line, and the stock goes up. Now they are turning around and overbidding the homes. And that's very scary for ordinary people. I drive down 101. I drive down 101 near Gilroy, okay? Oh my gosh, I can't believe it. There are homeless all over. I look at on the side of 101, I see like mini tents all over, homeless people. I haven't seen that before. There is an extreme inequity going on in the society. So you really don't want free money. I don't want free money, honestly. Don't give it to me, please. It's bad. If you need it, I want to see that more people get. I want to see that people, those who need, they get more than 1,400. People, those who don't need it, don't give it to them. Anyway, so this is the fundamental principle how the economy works. So keep that in mind. Anytime government gives free money, it's bad for you. Government could, why 1,400? People are getting 1,400. Why not $1 million? Government could say, I'm going to give you $1 million. What's going to happen? Then the price of a car, or price of a car is going to be probably $3 million. I don't know. I'm just making that number up because you can afford to pay 1 million, right? It's easy, free money. So why not increase the price? This is called inflation. Money's value is going down. So free money is not desired. Anyway, back to our problem. A little bit of hints on a little bit of knowledge on how economy works. As a young person, you may not know these subtleties and nuances. I think you should know about it, okay? Because this is how your life is going to be impacted. Because you need a home more than $1,400. If your home is something you cannot afford, that's bad. If the price of milk goes up, price of bread goes up. These are basic things. And if you look around the restaurants, prices have gone up. I don't know if it's going to come back down. Maybe, or maybe not. All right. Enough. Back to our bottom 5% of the population. All right. So as a mayor of the city, you want to find out who the bottom 5% of the people, maybe you want to give them some incentives so that they can improve their financial lives. Okay. They can improve their financial lives. Now I'm gonna do a little bit of erasing here. Let's take this off. You want to find the bottom 5%. So let's go ahead and do the following. Let's deal with the standard normal distribution, mean of 0, and standard deviation or sigma of 1. So bottom 5% would be somewhere here, okay? Bottom 5%. So that area is 0.05, keep it in mind. Area shaded is 0.05. Area shaded is 0.05. Now, also keep in mind all the area under the curve, is 100% or 1, okay? So this is 0.05 or 5%, 0.05 or 5%. Now, you want to find this point that there is going to be a z value, okay? If your z value is that, you are going to be including the bottom 5%. Now, we can take this z value and translate into the corresponding point here. That's going to include the bottom 5% for this normal distribution, okay? That's going to include the bottom 5% for this normal distribution. Now, this is where we kind of need to go back to the standard normal distribution table and find out the value. So there you are. Now remember, if your probability or area less than 0.5, you'd be in the negative z-scores area. If your probability or area is less than 0.5, you're going to be on the negative side. I mean, yeah, in the negative z-scores table. So let's go back. This is a special value, 0.05. And as you can see right here, there is a star mark. So this is 0.0505. This is 0.0495. Okay. 0.0505 and 0.0495. Between these two, you get this value. Okay. 0.05 is in between. So negative 1.645. Negative 1.645. So this is going to be negative 1.645. Now, corresponding to this z value, there will be an x value right here. X is equal to something. Okay. Now, how do we go back and forth? Remember, z is equal to x minus mu over sigma. Okay. Or in our case, actually, z is equal to x. Yeah, I guess we can use it. I'm not going to just worry about that. Z is negative 1.645. Negative 1.645 is equal to x minus mu. Mu is the average, which is 35,000. Mu is the average, and sigma is 7,000. 7,000. Now, to solve for this, what we are going to do, we are going to multiply both sides of the equation by 7,000. Why am I multiplying by 7,000? So that they cancel these, and this is going to cancel. So it's going to be negative 1.645 times 7,000 is equal to x minus 35,000. So let me use my calculator. Negative 1.645 times 7,000 is going to be negative 11,515. Negative 11,515 is equal to x minus 35,000. Now you add 35,000 to both sides. Add 35,000 to both sides. Now, if you add 35,000, is 23,485. 23,485 is equal to x. All right, so that's what it is. So 23,485. So as a mayor, you might be saying, oh, okay, if someone makes less than or equal to $23,485, okay, or roughly about $24,000, okay. In your city, if somebody makes less than $24,000, they fall in the bottom 5%. Bottom 5% of the income level. Bottom 5% of the income level. Now, you may want to design or develop policies that's going to benefit these people. Okay. So that's where you could use the knowledge of statistics. Okay. You can use your understanding of statistics and apply it into a context where it benefits you. It benefits the society. Statistics is a subject. It has a wide range of application. Okay. And it is not the kind of math that you may be thinking like 2 + 3 is equal to 5. Okay. It's not as precise as this. It has some degree of randomness or uncertainty. Okay. It could be applied to pretty much anything. Okay. Social sciences, psychology, medicine, workplace, economy, everywhere. So it's good to have good knowledge of statistics. Any question, anybody, about the bottom 5%? Everybody okay? How to find bottom 5%? All right. Good. Now, let's clean up the screen, and I'm going to ask you a question. Okay. Now, can you tell me, what if, as a mayor, you want to find out who are the top 5% of the people? Who are the top 5% of the people in terms of economic well-being or in terms of earnings? And maybe what you can do, you can impose a little extra taxes on the rich and maybe use that money to create social programs for the poor. Makes sense. Makes some sense to me. People, those who are well off in the society, maybe they could help. So we want to, this time, we want to find out the top 5% of the people, okay? So unlike the last time, this time we are looking for the top 5%, not bottom 5%, top 5%. Top 5%. Unlike the bottom 5%, we are looking for the top 5%. What should be the income level? What should be the income level? What should be this X value so that we have an income? If anybody makes at that or above, if anybody makes more than that much money, they are among the top 5% of the wage earners. Now, I'd like your help. How should I go about doing this problem? I just did one for you. Exact similar. Anybody wants to join in and talk? Juan Perez, what do you think?
Would it be like 100 subtract whatever number that we got last time? Because doesn't the whole curve like equal out to 100? And so we're trying to find out that little piece.
Kind of yes and no. Kind of. We will be doing something subtraction from 100, but I'm not sure if you are doing the subtraction for the right reasoning. Okay, good try though. Good try. Alicia, anybody else wants to try what's going on here? Remember, we are trying to find the top 5%. To find the bottom 5%, what did we do? We went to our standard normal distribution, right? 0 and 1. We went to our standard normal distribution between 0 and 1, right? Now, we looked at the left side, right? We looked at the left side last time. So, but this time, we're not going to look at the left side. We're going to look at the what? Right side, because we're looking for the top 5%. So we are looking for this Z value. Now, this area is going to be top 5%. Okay? This is going to be top 5%. Now, or this area is 0.05, area to the right is 0.05, area to the right is 0.05, exactly. Now, again, we have to go back and look at the table. Okay, standard normal distribution table, inside the table. Okay, inside the table. All right. Inside the table, we need to look at. So what do we do? How do we look at? Or where do we look at? This is important because if you don't get this part, you are not going to be able to do similar problems. And it kind of requires a little bit of understanding. Anybody wants to say which area am I looking at on the table? Okay. Now, first of all, if you look at the standard normal distribution table, it gives you area to the left of the point of interest. It does not give you area to the right. So that's one very important thing all of you should know and remember. It gives you area to the left. So if you look at the standard normal distribution table and look for area of 0.05, you're actually getting this point, which is, by the way, negative 1.645. We just found it. Okay. This is negative 1.645. So we need to look at this area, big area to the left, which is 1 minus 0.05, which is 0.95. 1 minus 0.05, which is 0.95. Okay. So if you look at the table, so let's bring back the table. 0.95, that's more than 0.5. We are going to be looking at this table. As it turns out, positive side. We're going to be looking at the positive z-score. Okay. Look, so sorry, let's try to move it a little bit further. Look, 0.95 is a special value, which is right here. Okay. 0.9495 to the left and 0.9505 to the right. The middle of this, look, this number is 1.645. Okay. So this number is going to be 1.645. So if you look at the z value associated with 0.95, is going to be 1.645. Okay. All right. Now, here is the thing though. Okay. Here is the thing. You can do it this way, but another thing you could think of is this. The area to the left here, okay, is 0.05. Area to the right is 0.05. Now look, this is negative 1.645. And I told you normal distribution is symmetric, meaning left is a mirror image of the right. Normal distribution is symmetric, meaning left is a mirror image of the right. So if this point is negative 1.645, this point to the right is going to be positive 1.645. Do you see? Positive 1.645. And that's exactly how you could do it too. If you look up for 0.05 area, then you're going to get the negative, but you're looking for 0.95, which is here. To the right of 0.95 is 0.05. So that's going to be opposite sign. The same value, but opposite sign. Now we can find this x value right here by using the z formula. Z is equal to x minus mu over sigma. In our case here, we got 1.645 is equal to x minus 35,000 divided by 7,000. Okay. Now you multiply both sides by 7,000. So there's going to be 11,515. 11,515 is equal to this, and this cancel out. Then x minus 35,000, so plus 35,000 x, this cancel out. So 35,000 plus 11,515, there's going to be 46,515. 46,515. So this is going to be 46,515. So if roughly someone makes more than 46,500, right? That person would be among the top 5% of the wage earners in the city. If someone makes above 46,500, that person is going to be among the top 5% of the wage earners. Now, remember last time we did bottom 5%? That was approximately, I think, 24,500, approximately. Let me put 24,500. No, about 24,000. I take it back. No, 24,500. Okay. It's slightly less than that, 23,000 something. I forgot the number. Actually, maybe, no, I have it. 23,485. So let me just write the exact number. 23,485. All right. So if you make less than or equal to 23,485, you are among the bottom 5%. So this is bottom 5% boundary, right? And this is top 5% boundary, okay? This is top 5%. So to be among the top 5%, you have to make more than 46,500. To be among the bottom 5%, you have to make less than 23,485. Okay, so that's good. Now, what if I want you to find out the next question? How much do you have to make to be among the middle 90%? Middle, how much do you have to make to be among the middle 90% of the wage earners or middle class of the society? Okay, that problem is actually already done for you, because bottom 5%, 23,485. Top 5%, 46,515. Okay, to be among the middle 90%, which is right here, you have to make between 23,485 and 46,515. To be among the middle 90% of the population, you have to make between 23,485 and 46,518. That's what it is. So in the exam, I could be asking you a question, something like this. Instead of 35,000, I might give you 45,000 average income. Instead of 7,000, I might give you 10,000 standard deviation. So mu would be 45,000, sigma would be 10,000. Now, all you have to do is this. You just have to you just have to find out the bottom 5% or bottom top 5% or middle 90%. Okay, bottom 5%, top 5%, or bottom 10%, top 10%. If we have bottom 10% and top 10%, okay, bottom 10% and then top 10%, the bottom 10% and top 10%. All right. Bottom 10% and top 10%. You can find that. Only difference is that in that case is going to be, instead of 0.05, is going to be 0.10. Okay. Again, here instead of 0.05 is going to be 0.10. Then you'll be finding the middle 80%, because to the left 10%, to the right 10%, 20% is gone. Then you're going to be finding the middle 80%. And that's how you'll do this problem. Now, this is a complete problem. I spent good amount of time on this. Hopefully, you guys are okay with it. Can I ask you whether you have any questions on this problem? Can you tell me if it's okay? Everybody is doing all right with this problem. This type of problems, you can do it. Okay. Now, I'm gonna give you another problem, and quickly, I'm gonna give you a minute to work on it, okay? And just tell me the following. You don't have to do the whole problem. Everybody do this. So again, 35K and 10K. 35K and 10K. We want to find the bottom 10%. Bottom 10% of the wage earners and top 10% of the wage earners. Bottom 10% and top 10%. So to find that, just let's do the one, okay? Just one part. Bottom 10%, we need to find this Z value. Here, this area probability is 0.10. And we want to find the corresponding area here. For that, we are going to find the X value. And we know this area is also 0.10. And I'll give you a minute, everybody, to look it up on the Z-scores table and find the Z value for this and do the calculation using the Z-scores formula. Z is equal to X minus mu over sigma. Z is equal to X minus mu over sigma. Okay. So please go ahead and spend a minute or so to do this problem. Okay. Then I'll ask you a question on this. Oops, sorry. I just realized that my microphone was off. I was muted. I asked you questions. So anyway, let's go ahead and ask you questions. So anybody wants to participate? What is the Z value? Anybody wants to join in and talk about it? Jerry?
Yeah, it's Jerry.
Jerry, okay.
It's what I got for the Z value was negative 1.28.
Jerry got negative 1.28. Okay, let's check it if Jerry is right. Let's see. Who wants? Ulysses, do you agree with Jerry? Ulysses? Okay. Myjin, do you agree with Jerry? Myjin?
I think it's the Z value. Is it the 0.4602?
0.4602. So Myjin has another value. So let's see now. What about anybody else? What do you got? Anybody else who wants to share their value, Z value? Yes, Michelle, you said something? Okay, so let's bring back the table. First of all, you should be asking the question, the area. Remember, in continuous case, for the continuous random variable, probability is always defined by the area under the curve or area under the density curve or density function, okay? So that area tells you the probability. In this case, probability is 0.10 because we want to be in the bottom 10%, okay? So we need to find the z-score associated with 0.10. So now 0.10 is less than 0.50, so it should be in the negative z value, okay? Negative z-scores. 0.10 is less than 0.50, and it should be in the negative z value region. So let's bring the table back. So let's see. Positive z-score, negative z-score. Remember what you are looking for. It's very important to understand what you are looking for. You are looking for the z-scores. You're not given the z-score. So you should not be looking here. You should not be saying, oh, I'm going to look here and find it there. No, you are not given z-score. You're given the probability, and associated with that probability, there is a z-score or z-value. You need to find that. So we should not be looking at the first column and look at the top row because we don't know what the z-value is. But rather, we should be looking at the body of the table, this body of the table. And we should be finding the area closest to 0.10 or 0.10. If we look at the area 0.10, the closest value I see is this value, 0.1003. That's the closest, because 0.0985 is smaller than 0.1. 0.1020 is bigger than 0.1, okay? So 0.1003, that's the closest. Now, if I look at the corresponding row, it's negative 1.2. If I look at the corresponding column, that's 0.08. So negative, so forget the sign, 1.20 and 0.08, that is 1.28, but it's negative, right? So it's going to be negative 1.28. That's exactly what it should be. And that's exactly how you should find it. That's what Jerry had it. Now, somebody else said some value. I forgot who said that, but let me bring that 0.46. And I'm going to tell you how you got the 0.46 too. You looked at 0.10, that's the area. So you probably went to 0.1, okay? There you go, 0.1. You looked at this point, negative 0.1, and you found that 0.46. Remember, this is not the area. This is not the z-score. 0.10 is the area. Look, let me take it back. See, 0.10 is the area, this shaded region on the left, this shaded region on the left. Okay, so once you're given the area, you should be looking inside the table. Okay, you should look inside the table and then find the corresponding z-score. On the other hand, if you know what the z-value is, you look in the first column and then you look along the first row on the top and then find the corresponding value somewhere in the middle here. Okay, that's how you'll do it. Okay, so now let's bring back. Now z is negative 1.28. So what is the corresponding x here? We're going to do z is equal to x minus mu over sigma. Z is negative 1.28 is equal to x minus mu is 35,000 divided by sigma is 7,000. Okay. Now we multiply both.
10,000?
Oh, is it 10,000? Oh, I meant to say 7,000. So leave it just 7,000. Okay. It was 7,000 in the last one. So let's just do it 7,000. Then multiply these by 7,000. So negative 1.28 times 7,000. That's going to give you negative 8960. So I'm going to just bring it here. Negative 8960 is equal to x minus 35,000. Okay, x minus 35,000. Now, if I add 35,000, we are going to get x. These two are going to cancel out. So plus 35,000 is 26,040. So x is 26,040. Okay, so 26,040. So if you make less than 20, roughly about less than $26,000, you'll be among the bottom 10% of the wage earners, bottom 10% of the people in the society in terms of economic well-being. Okay. Now, again, next time, if I turn around and tell you, what about the top 10%? Then all you have to do is this. This time, this is going to be your 0.10. This is going to be your 0.10. Okay. This is going to be 0.10. And now, what is this point going to be? So corresponding to here, this is going to be 0.10 or top 10%, right? Right? Now, this point, you don't have to do the calculation anymore. You don't have to look it up on the table. It will be just positive value of this, which is going to be z is equal to 1.28. Remember, bell-shaped curve are symmetric. That means they are mirror images of each other through the middle. Okay. Left is a mirror image of the right and right is a mirror image of the left. So we are using that property. So if on the left side is 10%, on the right it's 10%. If it is different, then it doesn't work. It has to be the exact same percentage on both sides. On the left side is 10%, on the right is 10%, okay? On the left is 10%, on the right is 10%. So if the left z-score is negative 1.28, the right z-score is 1.28. All right, so that's positive. Now, having said that, we could find the top 10% z is equal to x minus mu over sigma. Z is 1.28 this time. Instead of, only difference is that here we use the negative value, here we use the positive value. X minus 35,000 divided by 7,000. Okay, now I multiply both sides by 7,000. Okay, top by 7,000. These cancel out. So the bottom, I'm gonna get 8, on the left, I'm gonna get 8960. On the right, I'm gonna get X minus 35,000. You add 35,000. Okay. That's gonna give you 35,000 plus 8960 is equal to 43,960. So if you make X is equal to 43,960, so if you make more than, let's say, roughly about $44,000, you're among the top 10% of the income level. Okay. So if you make less than 26,000, you're in the bottom 10%. If you make more than 44,000, you're in the top 10%. What is the middle? 80%. So the 10% to the right, 10% to the left. 100 minus 20. 100 minus 10 minus 10 is 80, right? So middle 80%. So to be among the middle 80%, you have to make between $26,040 and $43,960. So this problem is a complete problem in and of itself, and I have given you 2 different examples using the same numbers. Okay, here we found again, last time we did it for 5%, bottom 5% and top 5%. This time we did it for bottom 10%, top 10%, and the middle is in this case 80%. Remember, 80% comes from the fact if you take away top 10% and bottom 10%, which is 20% from 100%, you're left with 80. And that's where the 80% comes from. Now, you should be able to do, who said that you have to do this? You could find top 25%, okay, and bottom 25%. Then what is going to be in the middle? If you have top 25% and bottom 25%, what is going to be in the middle? Is going to be middle 50%, right? So you should be able to find these different percentages. Any question, anybody? No questions? Everybody okay with it? All right. I'll go ahead and assume that you're okay. Now let's go back to the problems, normal distribution problems, okay. It's the same problem, same type of problem. So I'm gonna go ahead and do all of them, okay? So that you guys can feel comfortable with it. So these are practice problems. I gave you these ones, what we did there before. Now, the incomes in Dhaka, Bangladesh, the capital of Bangladesh, is normally distributed with $1,500, okay, mean $1,500, and the standard deviation $300. Find the following probabilities for a randomly selected person from Dhaka. Again, here we exclude extreme values, exclude extreme values, okay? So, extract the important values, mean, standard deviation. So mu is 1,500 and sigma is 300, standard deviation. Mu is 1,500 and sigma is 300. Now find the probability that someone makes less than $1,000. Okay, so I'm gonna clean up the thing. So we want to find let's say, probability that a randomly selected person makes less than $1,000. All right. So remember our mean is 1,500. Standard deviation is 300. So if middle is 1,500, where is 1,000 gonna be? It's probably gonna be somewhere to the left, 1,000. We want to find the probability that someone makes less than 1,000. So we need to find this probability. However, we cannot find it as it is. We have to use the standard normal distribution, and we can easily do it. Standard normal distribution 0 and sigma is 1. Standard normal distribution 0 and sigma is 1. All right. Now we need to take this x value of 1,000. This point is 1,000, and convert it into the corresponding z value. There will be a z value, and from the standard normal distribution table we can find this area, and this area is going to be exactly the same as this area. Okay, we have to find the area to the left here, okay, from z-scores. And then once we find this area, this shaded region right here is the same as this shaded region. So in essence, we are finding the probability that someone makes less than $1,000. So we can go back and forth between these two distributions. One is the standard normal distribution, and this is just any normal distribution, not standard. Z is equal to x minus mu over sigma. Okay, so we are going to find the z value by using the following. Z is equal to x minus mu over sigma. X is 1,000 minus mu is 1,500 divided by sigma is 300, which is going to give you negative 500, because 1,000 minus 1,500 is negative 500 divided by 300, which is going to give you negative 5 over 3, which is negative 1.67 roughly. Okay. I'm just rounding it. It's 1.66, so it's negative 1.67. I rounded it. So now you look it up in the table. So finding the probability that someone makes less than $1,000, falls below $1,000, is the same as finding the z value less than negative 1.67. And this is one very important point. Finding the probability that a randomly selected person makes less than $1,000 is the same as finding, okay, is the same as finding that z is less than negative 1.67. All right, this is very important that you realize it. This area is the same as this area, and this area is represented by this because z is negative 1.67. Okay, we found it here. So this point is negative 1.67. Corresponding to this point is this point, which is 1,000. Okay. All right. So negative 1.67. So we are going to find it from the table. Now this time you are given the z value. We are saying that z is less than negative 1.67. Z is less than 1.67. Okay. Now let's go back to the table. Okay, this time we are going to look for z. negative 1.67. So let's look at this table. Okay. Let me just clean it up for a second. Negative 1.67, negative 1.6 right here. Negative 1.6. Then if we go all the way up to here, so if we keep going right here, okay? 0.0475. That's what the value is gonna be. 0.0475. The area to the left is 0.0475. So let me just take this back and bring it back. So this area is 0.0475. Then this area is going to be 0.0475. So this is 0.0475, which is the same as 4.75%. It is the same as 4.75%. So the probability that a randomly selected person makes less than $1,000 is about 4.75%. Now, I think I have done this problem too here. Let me see. Did I make a mistake? Oh, there's a mistake here. I didn't make a mistake. This is a mistake. It should be negative 1.67, not 0.67. So for 0.67, I got this answer. This should be negative 5 divided by 3 is negative 1.67. So there is a typo here. Please fix it. This should be negative 1.67. Okay, and then if you change this number is going to change to 0.0475, and 0.2514 you got, that's for this value. Okay, all right, so hopefully this makes sense. Now let me give you another example just to make you feel at ease with all these things. Same income and everything. Let's find the probability that someone makes less than, let's say, $1,200. Okay, what is the probability that someone makes less than 1,200? And as you know, for the continuous case, less than and less than equal to is the same thing, because probability of a single point is 0. So now we are gonna go and do this. So this is the mean, which is 1,500, right? And this is the standard deviation, 300. We're gonna go to the standard normal distribution table. This is a mean of 0 and standard deviation of 1. Mean of 0 and standard deviation of 1. So less than 1,200, so which is gonna be right here, 1,200, right? So we are looking for this area. Less than, always shade these regions, then it's gonna be good. Less than 1,200. So now we have to find the corresponding z value here that corresponds to this, sorry, not 1,200. We're gonna have to find that z value, and that's gonna be equal to probability of z less than. So this area is gonna be less than that. So now, how do I find this value? Easy. Z is equal to x minus mu over sigma, or x is 1,200 minus mu is 1,500 divided by 300, which is negative 300 on the top. 1,200 minus 1,500 is negative 300 over 300 is -1. Okay, so that's -1. So that's the same as probability of z less than -1. All right, probability of z less than -1. Now, all of you, I want you to look for z less than -1. That means look it up in the table and give the number to me. It should be very easy. So please look at the table that I gave you. It's in the class notes. Everybody, please look at it and quickly give it to me.
0.1587.
Yes, thank you, Majen. 0.1587. Exactly. If you look it up in the table, you'll see that is 0.1587 or 15.87% chance. 15.87% chance that someone will make less than $1,200. Okay, so that's what it is. The probability that someone will make less than $1,200 is 15.87%. Now I'm going to ask you I'm going to leave this exactly as it is, and now I'm going to ask you this: find the probability that someone makes more than $1,200, right? More than 1,200. So in that case, you're not looking to the area to the left. This is not the area of interest, but rather area of interest is everything to the right. That's pretty easy, by the way. X is 1,200, right? So 1,200 converts to -1, right? So it's going to be probability of z greater than -1. Instead of z here, z less than -1 is going to be greater than. Easy. So that's the area to the right we are looking for. This area must be equal to this area, right? Now, how would I find that? You guys should know it. As a matter of fact, you do know it. I told about it in the last class. Okay. Jerry, how do I find it?
I'm not too sure.
Okay.
Would you take 1 and minus the 0.1587 to get 0.8413?
Exactly. Thank you, Majin. See, all the area under the curve is 100% or 1, right? Remember that thing. All the area under the density curve is 100% or 1, always, right? So if your left side is 0.1587, so the left side is 0.1587, right? What is the right side? So the right side should be 1 minus 0.1587, which is to say this is the same as 1 minus probability of z less than -1, which is to say 1 minus 0.1587. 1 minus 0.1587, which is 0.8413. That is 0.8413. That's what it is. So if you understood this, you understood a lot, okay? So this is how you're going to find out probabilities. Now, if I were to ask you, okay, find the probability that someone makes less than, let's say, 900, okay? So find the probability that someone makes less than 900. So let's go ahead and do it. Find the probability that someone makes less than 900. Again, we're going to draw this. So 900 is going to be right here. Okay. Zero, one, and we are going to do the z value here. What is the z value? Can somebody quickly tell me? It's pretty easy. X is equal to 900 and z is equal to so 900 minus mu is 1500. Oops, I made a mistake here. This is 1500. This is 300. Sorry about that. This is what I meant to say. So 1500 divided by 300, which is negative 600 over 300, which is negative 2. So z is negative 2. So that's the same as probability of z less than negative 2. So this area and this area are the same. So now somebody look at the table and give me for z is negative 2. What is the area to the left? Standard normal distribution table always gives you area to the left. What is it? Yeah. So somebody other than Myjane, somebody other than Myjane. Yeah, Alicia, go ahead. Point what?
0.4207.
0.420. That doesn't sound right, honestly. No, that
For
not doesn't sound.
negative
That's
0.2.
wrong. That's definitely wrong. So I was thinking 0.0 something. Okay, no, that is not right. You have to look at the z value of negative 2 on the table. Z value of negative 2 to negative 2.0.
2.0. Oh, 0.28.
No,
I mean 0.0228.
that's more like it. 0.0228. Now it's
Sorry.
right. Okay. So which is the same as 2.28%, which is the same as 2.28%. Okay. That's what it is. All right. Now, what if I ask you, what is the probability? What is the probability that someone makes more than 900? What is the probability that someone makes more than 900? It's the same thing. Probability of z greater than negative 2, right? Which is the same as 1 minus the probability of z less than negative 2, which is 1 minus 0.0228. So 1 minus 0.0228 is 0.9772. 0.9772 is equal to 97.72%. Okay, 97.72%. Okay. That's how you will do this problem. Now, yet another type of problem that I'm gonna do here is this. This time, what is the probability that someone makes between, let's say, 1200 and 1800? Okay, that's what we're looking for. So this is 1500, 300, 1800 is here, and 1200 is here. So you have two X values here, okay? We want to find out this probability, what is in the middle. This time is different. We want to find out what is in the middle. Now we are gonna do here, okay? So 1200 translates to something else, okay? So there is gonna be Z value here. That's gonna go for 1200. And then there is gonna be another Z value here. That's gonna go to 1800. So let's find the Z value associated with 1200. We just did it, okay? But I will still do it. Z is equal to X minus mu over sigma, or X is 1200 minus mu is 1500 divided by sigma is 300. If you do the math, negative 300 over 300, which is equal to -1. Okay, so this Z value is -1. Now, the other Z value, Z is equal to X minus mu over sigma, which is 1800 this time, 1800 minus 1500 divided by 300 is 1. So this is your 1. So Z goes between -1 and +1. Look, X goes between 1200 and 1500, right? I mean 1200 and 1800. X goes between 1200 and 1800. Z goes between -1 and +1. So that is the same as probability of -1 is less than Z is less than 1. That's what it is. All right. X between 1200 and 1800 is equivalent to Z between -1 and +1. Now you have to look at the table and find two values, not one. Now I have to kind of teach you here something. First, you find the value for higher value of Z, okay? The area associated with the Z of 1. So that means this. If you are finding the area associated with Z of 1, it's not giving you the shaded region. It is not giving you the shaded region only. It's giving you shaded region plus this area to the left. Remember that, because standard normal distribution table is cumulative from the left. What it does tell you that it gives you all the area to the left of this point of interest. So everything to the left of Z is equal to 1. Everything to the left. All right. Now, what we are going to do, we are going to do this. We kind of don't want this black circled area. What we can do is find the value for Z is equal to 1 and then find the value for Z is equal to -1, which is going to give you all the area from here to the left. We could subtract this. If we subtract this left area, this area, we are going to be left with the middle area, okay? We are going to be left with the middle area. So this in essence becomes probability of Z less than 1, which is everything to the left of this, right? Minus the probability of z less than -1, which is everything to the left of this point. If I subtract this from this, I'll be left with this middle region. Now, everybody go ahead and find the values for z is equal to 1 and -1 and tell me. I want to give you the opportunity to find these values, okay? I'll give you 30 seconds. Okay, what values did you get? For z is equal to 1, what did you get? Tell me. Anybody? Z is equal to 1?
0.8413.
Exactly, 0.8413. That gives you all the area to the left, but we don't want that. We want to exclude this area, okay? Now somebody else give me the other number. That one should be easy. We already have found it once. Okay, let's see. Jackie Mendoza. Jackie Mendoza. Are you on the line, Jackie Mendoza?
Yes, I didn't quite understand it
But you didn't ask me either.
because I was trying to figure it out on my own, but I didn't get it.
Why would you want to figure it out on your own in the class? You should be asking questions. Figuring it out on your own should be outside of the class. If you're not clear, you should be asking. I'm way beyond, okay? If you cannot figure it out during the class, when I'm helping, you won't be able to figure it out that easily after the class, okay? So it is important that you not only just be on the Zoom meeting and just sit down there, ask questions, okay? That's what participation is, for everybody, not for you only, for anybody. Okay, let's see. Jonathan Martinez, what is the value?
I'm still figuring it out.
What are you doing? You're figuring it out. I already have talked about it like 15 minutes ago, not once, multiple times. It's not class is not figuring it out. Class is to be participating and asking questions if you don't understand it. So everybody, please keep that in mind. Because online class doesn't, virtual class doesn't mean that you're going to be sitting down there and, oh yeah, I'm there. That is not the objective of the class. This value, we already found it, 0.1587. So if you subtract and please do keep in mind, I'm gonna be taking that into consideration when I do the final grading. People, those who are participating versus those who are just sitting down. If you are in the borderline, I'm here to help you. I go my way out of my way to help you. If you're in the borderline, I will have no mercy on you. Okay, if you are getting 65%, whereas 70% is a C, I'll have less sympathy for you because you have not shown any interest. You're just there, or you're not. As far as I'm concerned, maybe you're sleeping. I don't even know if you're there, or you're doing something else, texting or whatever it may be, if you're not participating. So please make sure that you do participate. Okay. All right. 0.8413 minus 0.1587, which is 0.6826, which is 68.26%. And this is a very important number. Why is this number very important? Because we have dealt with it before. Look here, so I'm going to use red. Here, your mean is 0. From the mean, you went to the right by how much? 1 standard deviation. From the mean, you went to the left by how much? 1 standard deviation. So you move 1 standard deviation to the right and 1 standard deviation to the left. You include what percentage of the data? 68.26% of the data. So you approximately include 68.26% of the data. Remember, empirical rule that we talked about, we included about 68% of the total data if you went 1 standard deviation to the right and 1 to the left. Okay, you included 68% of the data. At that time, I didn't get to that precise number. The precise number, or more precise number, is actually 68.26%. I even said that it's roughly about 68.2%. Okay, but for the sake of simplicity, I just said, oh yeah, it is 68%. That's about it. Okay, so that's where it comes from. Now you know that where this number comes from, 68%, or to be more precise, 68.26%. If you go 1 standard deviation to the right, the bell-shaped curve from the mean. So if you have a bell-shaped curve or a normal distribution or Gaussian distribution, if you go 1 standard deviation to the right of the mean and 1 standard deviation to the left of the mean, okay, then you include roughly about 68% of the total data, or 68.26% of the total data. So going from 1500 here, the mean, to 1800 is like moving 1 standard deviation. Going from 1500 to 1200 is moving 1 standard deviation to the left. So you're moving 1 standard deviation to the right and 1 standard deviation to the left. So you include approximately 68.26% of the total data. So the probability or the chances that a randomly selected person would make between $1,200 and $1,800 in the city of Dhaka is about 68.26%. And that's where it comes from. Now you know the explanation behind it. Now we can do the same thing for z is equal to 2. Okay, so instead of going to 1800, if I go to 2100, there will be going 2 standard deviations. If I go to 900, there's going to be going 2 standard deviations to the left, 2 to the left and 2 to the right. So probability of x between 900 and 2100 is going to be the same as the probability of z between -2 and +2. And that's the same as probability of z less than 2 minus the probability of z less than -2. Now, if you do the math, so somebody, can you give me the value for z is equal to 2? So this one is going to be 0.9 something. For z.
0.9
Yeah, go ahead.
is 0.9772.
Exactly. Thank you. 0.9772 minus for -2, somebody else. For -2, z is equal to -2. Anybody else? Z is -2.
0.0228.
Exactly. 0.0228. So if I do the subtraction, 0.977 to minus 0.0228, that gives you 0.9544, which is the same as 95.44%. Okay, 95.44%. So remember, I told you if you go 2 standard deviations to the right and 2 standard deviations to the left of the mean, you include roughly about what? 95% of the data. That's the second rule of the empirical rule, or second part of the empirical rule. If you go 2 standard deviations instead of 1 from the mean, so from the mean, by going to 2100, you go actually 2 standard deviations to the right. By going to 900, you go actually 2 standard deviations to the left, all right? From the mean. In that case, you will include approximately 95.44%. So the probability that a randomly selected person makes between 900 and 2100 is about 95.44%. And then you can do the same thing for 3 standard deviations. So let's do the 3 standard deviations. So that'll be like going from 600 to 2400. And that's going to be probability of -3 is less than z is less than +3, okay, which is the same as probability of z less than 3 minus the probability of z less than -3. Now somebody tell me what is this value for z is equal to z is equal to 3. What is the value that you get from the standard normal distribution table? It should be 0.9 something.
0.9987.
0.9987. Okay, hold on. .9987. Okay, 0.9987 minus for z is equal to -3. Somebody else, please.
Point 0013.
0.0013. Thank you. 0.0013. So let me just subtract it. 0.9987 minus 0.0013 is it's 0.9974. Okay, which is 99.74% of the chance. So if you move 3 standard deviations to the right of the mean and 3 standard deviations to the left of the mean, you include approximately 99.5% of the data. That's what we said, okay? So this is pretty close, okay? 99.74% we found. This is probably a bit rounded or something, so we are not gonna get deeper into extreme details, okay? So roughly about 99.5% of the data. I'm assuming that I got these numbers from you guys. Probably, hopefully that's correct. This is slightly off, but it should be closer to 99.5%, I think. Sorry, it's 99.7%. I take it back. I'm wrong. I remember the rule doesn't say 99.5%. It says actually 99.7% of the data. So which is actually correct. So approximately 99.74%. So if you move 3 standard deviations to the right of the mean and 3 standard deviations to the left of the mean, you include approximately 99.74% of the data. You include approximately 99.74% of the data. That's what it is. Now, with this example, you saw how empirical rule works, okay? When you are going between 600 and 2400, you are actually going between 3 standard deviations. 3 standard deviations to the left and 3 standard deviations to the right, okay? So that is gonna be probability of z less than 3 minus probability of z less than -3. All right, so that's what it is. And 99.7% in the actual formula, but in reality it's probably 99.74% or so. So this is a lot of information, by the way. If you are seeing it for the first time, if I believe you are, right? Then it's gonna sound overwhelming, okay? It's gonna look overwhelming, but hang in. This is the second class I'm spending on this. I'm gonna spend even another class, yet another class, most of it, which is on Wednesday. I'm gonna go over these things again, just to make sure that you guys feel comfortable. And my recommendation would be actually taking a piece of paper and pen and writing these problems out and working on them on your own, okay? Look at the class notes that I sent you, work on these problems on your own, and you should be good to go, okay? Once you get stuck, collect your question and come to the class and ask me. That's it, all right? Collect your questions, come to the class, and I'll be happy to answer your questions. And I gave you example problems. So if you look at it, for each of them, I think I gave you some example problems. So right here, these are example problems. You can try them. You should try them because it takes a little bit of practice. You should try these problems and then come to the class with your questions and I could help you. And it needs a little bit of practice. This is very important. Once you understand these things, you are good to go, by the way. The rest of the semester is going to become easier for you once you understand what we did here, because the rest of the semester involves a lot of normal distribution, And we are going to be talking about finding areas, finding probabilities, all right? And you may want to look at these 2 problems. Here are a couple of problems, this on page 60. By the way, I think I got a question from one of the students about the page number. You see page number 60 here, okay? Page number 60 here. This is actually not the real page number. Yes and no. This is page number built into the class notes, okay? Then there is another page number that you will see here. Even though it says page number 16, but for this class notes is page number 760, but for this class note is page number 17. That's where I am at. So this page number that you see right here, that does not correspond to the actual page number in a way that you would see on the PDF file, okay? The computer generates a page number. This is actually generated by me and I break it down so these page numbers, they are in order, but not all of them are included. All right, so my recommendation would be to look ahead and solve these problems, okay? So next class, I'll go ahead and do more of normal distribution okay, and finish it off. Then we are going to start talking about sampling distribution and the central limit theorem. And that we'll spend a couple of classes on this sampling distribution and central limit theorem, because it's so important that it's central to the limit, central to statistics. Then we are going to jump into confidence interval. So I'm hoping that by the March 31st, okay, March 31st or so, which is a Monday, by that class we will be finishing the sampling distribution. If I can't, then maybe it will go to the next class, which is April 2nd. But then all of April and halfway through May, we are going to be doing a month and a half. We are going to be doing confidence interval and hypothesis testing and linear regression and correlation. So mostly hypothesis testing and confidence interval and a little bit of linear regression and correlation. So this is what we are going to be doing. Once you have a solid understanding of what I am talking about right now, normal distribution and how the probabilities and areas connected to each other, how the z-score and probabilities connect to each other, then you'll be in a good position to understand the next topics. And by the way, if you are getting overwhelmed with these materials, please do not feel so. It took me many repetitions to get a good feeling and good understanding for all of these concepts. This is not easy if you're learning it for the first time, which you are, okay? So these concepts are harder. It takes a little bit of time and repetition to sink in. So it is important that you look at these problems multiple times and struggle a bit. And then slowly you are gonna get the concepts. And sampling distribution is one such concept, and central limit theorem. It's gonna take time for you to understand. And we are trying to do all of these things in one semester. I understand these things because I have taught this course many times, okay? And in the beginning years of my teaching, I had to read these things before every class. I'd read it multiple times to make sure that I understand before I can explain it to you. Now I don't look at the class notes anymore because I have taught so many times. I just know everything because of the repetition. So you are just seeing it for the first or second time. So it will take you a lot more practice, maybe 3, 4, 5 times before you start to get a good feel for it. All right. And the important thing in the process is not to give up. Okay. Do not give up. Hang in there. Come to the class prepared to ask questions. I'm here to help you. All right. Thank you so very much. That's all for today. And we'll see you on Wednesday. And after Wednesday, we have spring break. The following next week is off, and we'll be meeting on the 31st after Wednesday's class. All right. So Wednesday, there is class. All right. Thank you very much.
Thank you.
Thank you.
Mhm.
Thank you.